Cool. 883. Projection area of 3D shapes. On an n by n grid, we place 1 by 1 cubes that are axis aligned with the x, y, and z axis. Each value v equals to grid ij represents a tile of v cubes placed on top of grid cells ij. Now we read the projection of these cubes onto the x, y, yz, and zx planes. Return the total area of all three projections. Okay. Seems maybe okay. There's some like, well, it's okay because you could simulate it, I think, because it's just 50, right? So computational geometry is like actually a lot of things related to points in the plane and like stuff like this. Uh, Mostly just a lot of stuff about convex hull and I forget the other thing. Like Renoir diagram or Delaney. I don't know if I'm saying that. Delaney, triangulations and stuff like this. But a lot of fun class. A lot of, but the thing with that class is that you learn a lot about different ways of doing things because there are like eight good algorithms to do like convex hulls, and they all have like a little bit different way of thinking about it, and that's why it's kind of cool actually. But anyway, okay. But yeah, for here, I think you could just project it. Everything is less than 50, right? So you could actually just manually, um, yeah, you just manually kind of run a for loop through it. Um, okay, let's just do, okay, x, y is equals 0. And then was it x, y, y, z, and what's the last one? Zx is equal to 0, and then that'll be my areas for those things. And then now, maybe I could even get smarter on the loops, but each one is less than 50. Maybe I could do, I wonder if I could be smarter about it. So this is the, yeah, okay. Actually, I think I'm just going to do something like you just take the max of an array based on the axis, right? What are these three things? Oh, I guess this is, well, the top one is easy. The top one is just a number of non-zeros. Top, front, and side. Okay. So top one is easy. Oh, that's. But yeah, I think this is just a case of breaking it down a little bit, like case by case a little bit. I don't know if Java helped here because I mean, because this is like any, this could, right now it could be a language, but shoe truck. I did not take anything of shoe truck, so probably not. I took computational geometry with someone called Professor, I think Joe Mitchell. I want to say something Mitchell. It's been 15 years, so let me Google him. Yeah. So yeah, very good, very kind, very patient. And then for the other ones, actually for the other ones, I was going to say something like you could maybe do the like storing a weight of height map, but you can actually just do it now, right? Okay, let's just do y sum 0, 0. And x sum 0, and that's just the max of the heights in the x element or the y element. Okay. Yeah. I went to Stony Brook in New York, out in Long Island. Uh, it's a very small school. I don't know if it's small anymore. I think, but it's not a well-known school though. Maybe that's what I meant to say. Okay. Max equals 0. Mm. Max. Is this right? I think in Java is this. Could be wrong. And then we can also go the other way. Yeah, I'll just put another loop. You could probably put in the same loop actually, but hey, really? Well, I mean, it was very good when I was there. I mean, not to be like, wait, can this be n? Okay, so I could do this. But yeah, when it was good in the sense that they had a. I mean, I was there as an undergrad, but they had a good grad program, so I started taking classes from it. Uh, so it was. I mean, I took a lot of classes. It was fun. But yeah, but I don't know if it's. Oh, you're going to Stony Brook. Oh man, sorry, I didn't scroll up. Uh, so you're still in high school? Well, congrats and good luck in Stony Brook. Yeah, I enjoy my time there. It's a little in the middle of nowhere though, unfortunately. But uh, but but it depends on where you're coming from. If you're uh, like if you like you can, it's a quick hop to New York City is what I mean to say in the weekend. So it's a little bit quiet, but um, but it's all right. This is right. Ooh, yum. Oh, cool. Oh, congrats. What? Oh, yeah. Yeah, I like Stony Brook. Yeah, I mean, I remember my just flashing back. Was it the Waff Pond and people swimming in it? Well, people tell you not to swim in it, but people swim in it. It's very smelly. Yeah, yeah, a long time ago, unfortunately. Even though it, you know, yay! Oh, all the other job ones is faster. Okay. Uh, oh, really? Huh. They used to, I don't know if they still do, but they used to pump water into the pond when it gets low. So it is fresh water, kind of. Uh, but anyway, cool. So yeah, so this is I think, yeah, so this is an easy problem, or like it's listed as easy, but a little tricky. I don't know why it has so many downloads though. It's not that bad. Um, I think I think some of it is that like even though I've been talking about this problem, so it allowed me to yeah looking into problems so that it allowed me to kind of really think about what I want to put. I think I didn't really articulate this very well. To be honest, I think well, first of all, yeah, like he 86 said, I had to look at to see what the inputs were, but this is the vertical, yeah, the cubes on top. So you're basically getting the top view, which is why this works. I mean, I think this is obvious, hopefully, because yeah, that's just the number of spaces occupied from the top. And then here, from the side view, I look at each like from a certain position. That I just take, you only see what's sticking out the most. So you take the max of that, and then just sum it up, and then that's one of your faces, and then the other face is the same way, but you do your for loop the other way, right? So So you look at it from the other direction. I don't know, but that's a little hand wavy, but that's the essential idea. But if you look at it in terms of a matrix, well, okay, these are bad examples or bad input, not bad inputs, just like not inputs that let me illustrate it. But basically, my idea is that oops, like given an array like this one, let's add some numbers. But yeah, but from the side we're going from this direction. You're only going to see the max of that row in this case. So that's going to be 5. This is going to be 2. This is going to be 3. So that's the logic. And the same thing from the columns. So for example, this is 2. You're going to only see the max. And so well, this is maybe a bad example, but so yeah. So then you just kind of sum up all these numbers, which is what the problem asks you, and that's how you solve this easy. Yeah, I mean, I don't know if this is I guess it's easy enough to be an interview question. I don't know. uh, I mean, it's not too hard, and it's just like a couple of for loops. You could probably do it in one for loop if you, oh, what the heck, okay. If you're a little clever, or if you want to save, but you could trade space for time that way, but it's only an additional pass. And obviously, this is all of n times, oh, it's n times n. Okay, but yeah, obviously it's all of n time or n square because you only go through the loop, the entire array 3 times. I mean, you could technically combine them a little bit, but it's not a big deal. And obviously constant space, so it's space optimal and time optimal. You could do it in fewer passes if you want, but then you trade some space for it, I think. This is it. I mean, it's an easy problem, so I generally say most easy problems, unless it's really hard. Yeah, and I'll point those out. You can assume it's fair game just because like it's a easy, and you could do in 3 for loops, or 3 sets of easy for loops. Then like, it's about saying that, and this one I think is a good like you could get far enough. You just have to actually like sit down and focus. I think is one of those problems. But yeah,